Welcome to The Explainer. Today, we are diving deep, right under the hood. We're going to be exploring the really fundamental design choices behind those massive data systems that power, well, everything from your social feed to global finance.
I mean, think about it. The scale is just staggering, right? And the answer? It's not some magic bullet, not some single piece of tech you can just buy off the shelf.
Nope. These things are built on a foundation of really, really tough choices. Every single decision an architect makes here has these profound, lasting consequences down the line.
So, for the next few minutes, we're going to put you in the architect's chair to face these choices head-on. Ready? Your journey starts now. Okay, so before you even think about writing a single line of code, you need a blueprint. And every truly robust application, I mean the ones that last, they're built on 3 core pillars. You get these right, you've got a solid foundation. You get them wrong? Well, you're basically building on quicksand. So, pillar number 1, reliability. Now, this doesn't mean your system is perfect and never fails. Come on, that's impossible. It means it's built to tolerate failure, to survive it. Whether that's a server just giving up the ghost, some buggy software, or yeah, even human error. Pillar number 2 is scalability. This is a big one. It's all about what happens when you succeed. When your app goes viral, you have to have a reasonable way to handle all that growth. You don't want 10 million new users to be the thing that brings your entire system to a screeching halt. And right away, this leads you to your first major architectural choice. Are you going to scale up? That's called vertical scaling, by just buying a bigger, beefier, way more expensive machine, or are you going to scale out? Horizontal scaling by spreading the work across a whole bunch of smaller, cheaper machines. These two paths have totally different consequences. And the third pillar, the one that honestly gets forgotten way too often, is maintainability. Look, you want to build a system that other people can actually work on. You know, the goal is for a new engineer to come in and be productive, to fix things, to add new stuff, not to spend 6 months just trying to figure out what on earth you were thinking.
All right, with that blueprint in mind, we hit our first huge decision. How are you actually going to organize all your data? You can think of it as the fundamental filing system for your entire application.
And broadly speaking, there are 2 big paths you can take here. First, there's the relational model. This is like a super organized spreadsheet, data in neat tables, rows, columns. It's awesome when all your data is interconnected. Or you could go with the document model. This is way more flexible. Think of it like a folder full of resumes. Each document is self-contained. Now, don't just brush this off as a small technical detail. This choice, as the quote here says, has a profound effect on what your software can do later on. It literally sets the rules for what's possible and what's not for years to come. Okay, so congratulations, your app is a hit. It's a massive success. The only problem? Your single database is just melting. It's completely buckling under the pressure from all the people trying to use your app. So what do? Well, the answer isn't just a bigger server. It's more servers. You've got to create copies of your data, like a clone army, to spread out all that work. This whole idea is called replication. And by keeping copies on multiple machines, you get 2 huge wins. First, availability. If one machine dies, another one is ready to take over. And second, you can spread out all those read requests across all the copies, which gives you a massive performance boost. But, of course, this brings us to the next big trade-off. Do you go with synchronous replication? That's where the main database waits for a copy to say, yep, got it, before moving on. It's way safer, guarantees you won't lose data, but it's also slower. Or do you go asynchronous for pure speed, where the leader just sends the data and hopes for the best? It's faster, but you accept a tiny risk that if the leader crashes right after a write, that data might be lost forever. So it's safety versus speed. What do you choose? So your app just keeps growing. It's a great problem to have, but it's still a problem. And now you've hit a new wall. You have so much data, it literally won't fit on one computer's hard drive anymore.
Okay, so replication was all about making copies of the same data. Now we have to do the opposite. We have to take one giant data set and break it up into smaller chunks, spreading those chunks across lots of machines.
This process is called partitioning. You'll also hear it called sharding. And honestly, it's the only way you can possibly handle datasets that get into the terabytes or even petabytes. Each machine is now only responsible for its own little slice of the pie.
And you guessed it. Here comes another critical choice. How do you split it up? Do you use key range partitioning? Think of it like volumes of an encyclopedia, all sorted. That's great if you need to scan through ranges of data. Or do you use hash partitioning? This basically scatters the data randomly. It's fantastic for making sure the load is spread out evenly, but it makes finding things in sorted order a lot trickier. It's another one of those classic trade-offs, organized queries versus balanced load.
All right, let's recap. Your data is now copied onto multiple machines, and it's split up across a whole bunch of other machines. With all this complexity, even a simple thing like updating a user's profile becomes this incredibly complicated dance. How on earth do you keep things from descending into total chaos?
I mean, just think about the classic example, a bank transfer. Money leaves one account, and then boom, the system crashes before it arrives in the second account. Where did the money go? It just vanished into thin air. That is the exact kind of nightmare scenario that we need an ironclad guarantee to prevent.
And that guarantee has a name. It's called a transaction. What it does is it bundles a whole bunch of separate steps together and treats them as one single logical unit. The whole group of operations either succeeds perfectly or it fails completely, and the system pretends like nothing ever happened. These guarantees are famously summed up by the acronym ACID. You can think of ACID as a contract for your data. A is for atomicity, that's the all-or-nothing part. D is for durability, meaning once it's done, it's done. It'll survive a power outage, a crash, anything. These properties together are really the gold standard for making sure your data is safe and correct.
So far, we've been talking about how to store and query data that's just kind of sitting there. But what if we just rethink what data even is? The really cutting-edge systems today, they don't see data as this static thing. They see it as something that's constantly moving, constantly flowing. Yeah, instead of data at rest, they think about data in motion. It's this endless, unbounded stream of events. Every single click, every purchase, every little update from a sensor, it's not just a new row in a table anymore, it's an event that gets added to this ever-growing, unstoppable log.
And this idea, it totally flips the script on how we process information. We go from the old world of batch processing, where you run a job on a big chunk of data, it finishes, and you're done, to stream processing. These are jobs that literally run forever, constantly reacting to new events, pulling out insights in real time as they happen.
But all of this power, the ability to process these endless streams of data in real time, it brings us to a really important final point. You see, these decisions we've been talking about, they aren't just technical details. They create these incredibly powerful feedback loops that directly shape people's lives and experiences. I love this quote. The thing is, data can only tell you about the past. It can only show you what's already happened. It takes a person, it takes moral imagination to look at that data and then build something better for the future. Our tools can't do that for us. That's our job as designers and architects. So in the end, the biggest, most important design choice of all, it's not about which database to use or how to partition your servers. It's about our intent. The systems we build are so incredibly powerful. And so the real question we have to ask ourselves as the architects is this: are we building the world we actually want to live in? That's the final choice.